everyone. So in the previous lecture we were discussing problems based on calculation of domain as well as range. So we will continue our discussion with the solving the problems particularly based on domain and range. So let us see more questions. So here in this question we have to find the domain of the function f of x equal to 1 upon square root of x integral of x square. This is integral of x square minus integral x minus 6. So f of x equal to 1 upon square root of this function. Now here, as far as the conditions for calculation of domain is concerned, for real x we should have y or f of x real. For finite x, f of x or y, it should be finite. So here, if we consider these conditions, then denominator it should not be equal to 0, as well as this quantity under square root it should not be negative, because if this quantity under square root if it becomes negative, it means again we will get square root of negative quantity, and when it is square root of negative quantity, so again that becomes an imaginary quantity and that is not accepted. So it means our condition, the required condition will be the domain should be such and x should belong to real numbers such that x square and integral of x square minus integral x minus 6 it should be greater than 0. Here you can see it is not equal to 0. If you see this inequality, we have not included equal to 0 because the denominator cannot be 0. In that case, this will become infinity, and that is again not part of the domain of the function as far as the conditions are concerned. So x square minus x integral of x square minus integral x minus x would be greater than 0. So let us simplify this inequality and we will consider. Just for your understanding, you can say suppose integral x is equal to suppose z, because this is quadratic integral. So just to avoid any confusion, you can assume or directly you can simplify integral x equal to z. So this will be equal to your z square minus z minus 6 greater than 0. Z square minus z minus 6 greater than 0. So we will factorize this, bring it to two linear factors, factorize it into two linear factors, and then just use the concept to solve any inequality, and we will be getting the value of z. Once you get this z, it means you will be getting the value of integral x. So directly considering this, we have the two factor integral x minus 3 into integral x plus 2. That you can do because this is very simple expression. So integral of x minus 3 into integral of x plus 2, that is greater than 0. Now again, as you know this inequality, if z minus a into z minus b, if it would have been greater than 0, then z is less than a and z is greater than b, provided a is less than b. If a is less than b, then this is the solution as far as this inequality is concerned. So we have used the same condition. Z means what? Integral x. So here this is minus of 2. So a means minus 2 here and b is 3. A is less than b. So a will be smaller constant here, it is minus of 2. The larger constant it is 3. So that will give you z less than minus 2 or integral x minus less than minus 2 or integral x greater than 3. So let us again consider this. So if you simplify this inequality, so as we have done, okay, so from here, from this inequality you can conclude integral x equal to minus 3 because it has to be an integer. So it is less than minus 2. Minus 2, it means minus 3, minus 4, minus 5 and so on. So all integers up to minus infinity. So minus 3, minus 4, minus 5 and so on. Similarly, when integral x greater than 3, so integral x greater than 3 means what? The nearest integer which is greater than 3 is 4. So it will be 4, 5, 6 and so on. So integral like that will be 4, 5, 6 and so on. So it means x should be greater than equal to 4. So here we are getting x less than minus 2. Here you are getting x greater than equal to 4. It means our domain will be what? This as well as this. This and this you can say, or this as well as this. Mathematically that can be represented as this union this. Greater than equal to 4 means 4 to infinity. Less than equal to minus 2 means from minus 2 to minus infinity. So minus 2 to minus infinity as well as union 4 to infinity. Now infinities are not included as far as the intervals are concerned. So here you can see this is small bracket, here also you can see small bracket. When we put any, like suppose if you put some interval like this under big bracket, so it means this means 2 less than equal to x, x less than 3. That means these two extremities are also part of the domain of the function or part of the solution. These are included, but 2 and 3 if it is not included, suppose 2 less than x, x less than 3, then we can represent like this. We can also represent like this. Just open the big bracket, it means 2 and 3 are excluded, or put it in, under this closed small bracket, means 2 lying between 2 and 3, but 2 and 3 both of them are excluded from the solution. So these are the various way as far as the intervals representations are concerned. So that's why infinity is not included. Any quantity can approach infinity, it cannot be equal to infinity, and that's why these two are excluded from the solution. So finally it is minus infinity to minus 2 union 4 to infinity. Now let us see the next question. So if you consider the next question, here we have to find the domain of the function f of x is equal to square root of 3 minus 2x minus 2 to the power 1 minus x plus square root of sine inverse x. So here there are two functions. F of x, if you consider this function as suppose phi x and this function as psi x, it means your f of x is equal to phi x plus this psi x. So whenever there is combination of the domain, suppose addition of 2, 3, 4 functions, or subtraction of 2, 3, 4 function, or addition as well as subtraction both, then we will first calculate the domain of all individual functions. So we will calculate the domain of the function phi x, we will calculate domain of the function psi x, and then the domain of the entire function, means the domain of this function f of x, it will be the common domain of this as well as this. And if suppose domain of this is d1 and domain of this is d2, then domain of this it will be d1 intersection d2, means the common of these two domains d1 as well as d2. So that we will do. So let us first calculate the domain of this function phi x. We have assumed this as phi x and this as psi x. So we will calculate these domains separately, and then we will find the common points out of that. So if you calculate the domain of this function here, then you can see this domain of the function, this one. Again, it should be so. If you just observe this, this is again under square root. So if this is under square root, okay, this is under square root, so again that quantity has to be what? Positive. It means 3 minus 2 to the power x minus 2 to the power 1 minus x, it has to be positive. So when, because it is under square root, Here again this is sine inverse function, and that is also under square root sign. So we will consider only those values for which this quantity is positive. Similarly here also for which this quantity under square root is positive. So that we will consider. It means domain this D1, it will be such that 3 minus 2 to the power x minus 2 to the power 1 minus x has to be greater than or equal to 0. And similarly sine inverse x has to be greater than or equal to 0. So if you simplify this inequality, so we can write this is 2 to the power, 2 divided by 2 to the power x, because 2 to the power 1 minus x, that is equal to 2 into 2 to the power minus x. So power is negative here, so we can write this as 2 upon 2 to the power x. So this is what we have here. Now 2 to the power x, 2 to the power x. Again you can assume 2 to the power x is equal to z. So can you say this will become, if you assume this, so this will be 3 minus z minus 2 upon z. Taking this z is equal to 2 to the power x. Just assuming that z is equal to 2 to the power x, just for your simplicity, you can write this equation, and this is greater than equal to 0. So first simplify in z, get the value of z, and once you get the value of z, it means you are getting the value of 2 to the power x, and from there you can calculate the value of x. So directly you can keep this 2 to the power x. If you find any confusion or any doubt, you can replace, you can assume this, and then you can proceed further. So here we can see 3 into 2 to the power x minus 2 to the power x whole square. Just taking this LCM and simplifying, so you will get this relation. Okay, because 2 to the power minus x, it is an exponential function. For any value of x, whether it is positive or it is negative, 2 to the power x, it will be positive. So if you write, if you take LCM and cross multiply, it will be 3 into 2 to the power x. So 3 into 2 to the power x minus 2 to the power x into 2 to the power x means 2 to the power x whole square minus 2. Denominator it will be 2 to the power x. Right side we have 0. Greater than equal to 0. In the previous lectures I have told you, when there is inequality and under the terms under numerator and denominator, if there is a possibility of that any of the terms it can be negative, then don't go for cross multiplication. But here it is clear that 2 to the power x, it is always positive, because suppose 2 to the power minus 1, so it becomes 1 by 2. 2 to the power minus 3, it will become how much? 1 upon this 2 to the power 3 and so on. So it becomes always positive. It can be less than 1, but it will always remain positive. So under that condition, 2 to the power x in the denominator here, it can be multiplied by 0, so that here you are getting this. So if I elaborate it further, you can say 3 minus 2 to the power x minus 2 to the power 2 upon 2 to the power x greater than equal to 0. So you can write, this becomes your LCM. Here it will be 3 into 2 to the power x minus 2 to the power x whole square minus 2 greater than 0. Now we can go for this cross multiplication. So here you can have this one and as well as this. So this becomes 3 into 2 to the power x minus 2 to the power x whole square and minus 2. It is greater than equal to 0, because this into this, that will be 0, and this is a positive quantity, so we are not violating any condition. So this is what it is mentioned here. And after simplifying, now again it is a quadratic equation in 2 to the power x. Again you can see this. So simplify this. Either you can take 2 to the power x is equal to z, so you will get z minus 2 into z minus 1 less than equal to 0. So what are the values? Again we will use the standard form of that inequality and we will simplify that. So you can just see this. So here you have this inequality. Now it means 2 to the power x, it will lie between what? 1 and 2. 1 is the smaller constant, 2 is the larger constant. So 2 to the power x, it will lie between 1 and 2. It will lie between 1 and 2, yani in this region. Okay, between 1 and 2. So 2 to the power x lies between 1 and 2. Both 1 and 2 it will be included as far as the interval is concerned, because here there is the equality sign and there is no violation of any other condition. So it means 2 to the power x belongs to 1 by 2, 1 or 2. So that means here you can see 1 means what? 2 to the power 0. 2 means what? 2 to the power 1. Now you can compare. There are other ways. We can go for the exponential function concept, we can go for the logarithmic, or we can just have a, because it is a simple term, so we can have some comparison here. So it means here it is 0, this 1 have been replaced as 2 to the power 0, this 2 have been replaced as 2 to the power 1. Now compare, base here it is 2, here also it is 2, here also it is 2. Powers are 0, x and 1. So it means your x lies between 0 to 1. So we have just used the comparison method and we have calculated that x lies between 0 to 1. So this is the domain of the function 0 to 1. This is for phi x. Now let us calculate for the other function, that is psi x, and psi x it was the square root of sine inverse x. Because of that square root, our condition is what? Sine inverse x, it should be greater than or equal to 0. This is 0 at x equal to pi by 2. So at x equal to pi by 2. So when it lies sine inverse x, when it lies in the first quadrant, all values are positive. So first quadrant means 0 to 90 degree or 0 to pi by 2. So that gives you 0 to pi by 2. So 0 less than equal to sine inverse x, x less than sine inverse x less than equal to pi by 2. So that gives you again So again, if you consider, this will be 0 to 1, and d2 it was what? 0 to 1. So the common domain again it will be 0 to 1 and union 0 to, because the first domain for phi x we got 0 to 1, the second domain for the second function we are also getting 0 to 1. So what will be the common points? It means both the domains are satisfying both the function, so the finally it will be 0 to 1. So this is the domain of the function. So f of x is such that its domain is 0 to 1, including 0 as well as including 1. Now let us see some more questions. So here again you can see in this question you have to find the domain as well as range. So f of x is equal to x square minus 3x plus 2 divided by x square plus x minus 6. So we need to calculate the domain as well as range of the function. So again we will use all the conditions required to calculate the domain of the function. So suppose f of x equal to x square minus 3x plus 2 divided by x square plus x minus 6. Now here there are no square root sign. It's a simple algebraic function in the form of numerator and denominator. It means the only condition required is the denominator, it should not be equal to 0. And this condition is the required condition is that x square plus x minus 6, it should not be 0. So we will eliminate those values of x for which this is 0, otherwise all real values of x will be the domain of the function, because for any real value of x here, this f of x or y it will be real, because we don't have any square root sign. There are no other conditions which will be violating the required or prerequisite to calculate the domain. So just simplify this, and this should not be equal to 0. So let us calculate for what are the values of x for which it is 0. So and we will eliminate those values. So x square plus x minus 6 equal to 0, simplifying and factorizing we are getting this. It means it is 0 at 2 and minus 3. So your solution will be x belongs to all real except 2 and 3. Except 2 and minus 3, because it is 0 at 2 as well as at minus 3. So these cannot be part of the domain of the function. So it means finally this is the domain. Now to calculate the range of the function, range means what? what is the maximum value of the function and what is the minimum value of the function, so that the function value lies between those two, minimum as well as the maximum value. This is also one of the way to calculate. So in calculus there are various ways to calculate. Either we can go for the maxima and minima concept and we can calculate the maximum value of this function and minimum value of this function. We have other concept also, taking help of the limits. There also we can calculate the minimum value as well as the maximum value, but right at this stage you don't know differentiation. So let us use the concept of this limit to calculate the maximum as well as the minimum value, so that the range of the function, it will be lying between that minimum as well as the maximum value. So after factorizing you will get this x minus 2 into x minus 1 upon x plus 3 x minus. So directly I am considering this because these are simple expressions and easily you can factorize. So x minus 2 x minus 1 upon x plus 3 into x minus 2, and this is equal to x minus 1 upon x plus 3 because these two will get cancelled. Now we are able to cancel out this because already we have assumed that the domain of the function cannot be what? 2 and minus 3. 2 and minus 3. So it means x is not equal to 2. When x is not equal to 2, then only you can cancel out this factor and this factor. Otherwise, if x is equal to 2, then this becomes 0 and this becomes 0. And 0 by 0, that becomes an indeterminate form. So we can't have any mathematical operation as far as the indeterminate forms are concerned. So here it is not the indeterminate form because x not equal to 2. We are not considering the domain of the function where x is equal to 2 or x is equal to minus 3. They have already been eliminated, and that's why we can cancel out these two terms and we can simplify, and you are getting this one. It means, so value of the function at x equal to minus 3, it will be how much? At x equal to minus 3, because this denominator becomes 0, so it will, if it is 0, it means f of x, it becomes infinity. So f of minus 3, it is infinity, and when f of minus 3 is infinity, it means you need to calculate again, to avoid any indeterminacy of the function, the limiting values of the function. So if you calculate the limiting value of the function when x tends to 2, x is not equal to 2 but x tends to 2, because 2 or minus 3, they are not part of the domain of the function. So when x is not equal to 2, so we can just calculate the approaching value or the limiting value, and calculating it is coming as 1 by 3. Similarly, if you calculate the value of this, so let us say this is equal to y, because we have to calculate the value of this range, means what? Value of f of x or value of y. So let us say this is equal to y. So if it is equal to y, so it means, just simplify, you can elaborate this x equal to minus of 3y plus 1 upon 1 minus 1 upon y minus 1. We have introduce the equation in such a manner that now here x is a function of y. So if x is a function of y, it means x will be behaving as the range and y will be behaving as the domain. And in that case, if we can calculate the value of y, that will become the range of this function, because we are interested in calculating value of y. So simplifying this, because y cannot be equal to 1, because again this term is in the denominator. Okay, so f of infinity, so when we calculate f of infinity, so you can't calculate the exact value because x is not equal to infinity, y is not equal to infinity, they can just approach infinity. So in that case, limiting value of this when x tends to infinity, and it is coming as 1. So see here, one value it can attain is 1 by 5 and another value it can attain is 1. It means the minimum value or the least value it can have is 1 by 5 and the maximum value that it can have is 1. So what is the range of the function? Lying between minimum and maximum, so it is 1 by 5 and 1. So your range of this this function, it will be all values of x except 1 by 5 and 1, because this is minimum and this is maximum. It cannot be lying between these two. And why it cannot be lying between these two? Because you can see here, y is not equal to 1, that condition we have seen. Similarly, x is not equal to 2 and x is not equal to minus of 3. So considering all those things, these values are to be eliminated. F of infinity, it has to be eliminated. So under all those conditions, 1 by 5 to 1, under this interval, all values are eliminated from the range of the function. So all values, all real values except values lying between 1 by 5 and 1. So this is the range of the function. So that way we can calculate. Other method is, once you have to calculate the range of the function, so we can go for the concept of maxima and minima of a function. So when we will discuss differentiation, again also we will see how to calculate the range of the function using the concept of differentiation, and with the help of that differentiation we will use the concept of maxima and minima. Now see this function. Find the domain and range of the function square root of 2 minus x plus square root of 1 plus x. Square root of 2 minus x plus square root of 1 plus x. So again there are two functions involved here. Again you can say this is suppose phi x and this is suppose psi x. Again we can calculate the domain of this function and this function separately and find the common point, and from there we will get the domain of the function f of x. So it means here, again this is under square and under square root. It means again what is the basic condition that we need to take? 2 minus x, it has to be greater than equal to 0, and again 1 plus x has to be greater than equal to 0. So just simplifying, 2 minus x greater than equal to 0, 1 plus x greater than equal. Here you can see these are just the representation. F of x, it is such that x belongs to interval such that 2 minus x, yani under that interval 2 minus x is positive, greater than equal to 0, as well as 1 plus x is greater than equal to 0. So these are the ways to represent. You can write, you may not write, you can directly move and you can simplify this. So 2 minus x greater than equal to 0 means x less than equal to 2. 1 plus x greater than equal to 0 means x is greater than equal to minus 1. So the domain of the function will be what? Greater than equal to 2 and x is less than equal to 2 and x is greater than equal to minus 1. Greater than minus 1, greater than minus 1 and less than 2. So it means it lies between what? Minus 1 to 2, yani between this point and this point. So it lies between minus 1 to 2. So this is the domain of this function. Similarly, we can calculate domain of 1 plus x, that we have calculated. 1 plus x, that will be x greater than equal to minus 1. So finally the domain of the function is minus 1 to 2. Now to calculate the range, we can consider, suppose f of x equal to this means y is equal to square root of 2 minus x plus square root of 1 plus x. This is suppose your y. Y means f of x. Range means we need to calculate value of this y. So when we calculate the value of y, so because right side terms are under square root, so to remove that square root from here or to overcome, we can square both the side, left side as well as right side. So y square or f of x square, that will be your square root of 2 minus x plus square root of 1 plus x whole square. Simplifying, just using a plus b whole square, simplifying, you are getting this, and finally we can arrange these terms like this. 3 plus 2. Here it is square root of 2 plus x minus x square. That can be arranged. Now why we are arranging like this? You can have this doubt why we are trying to arrange this. There are other ways to calculate. This is the simplest way to simplify the problem, such type of problem, provided you can arrange this. We are trying to consider this as a perfect square, because perfect squares, they are always positive. So if perfect square quantities, they are always positive. So here you can see we have arranged this term in such a that 9 by 4 we have taken this out as a constant term, so its value cannot change. Here the variable x is variable, so it has been arranged in such a manner that x minus 1 by 2 whole square, this is always positive. Whatever be the value of this x, this quantity will always remain positive because it has been arranged as perfect square term. Now 9 by 4 are minus this positive quantity. So depending on the value of this, either it will take the minimum value or it will take the maximum value. Minimum, if you take minimum value of this, then it gets maximized. If you take the maximum value of this, it gets minimized. So that is the concept here that we are trying to, or that is the logic here that we are trying to use this. So you can now see here. So 3 plus 2. Minimum value of this, it will be what? 0. So finally it becomes 9 by 4, and that gives you 6. This will be 0 at x equal to 1 by 2. So this is 0 at x equal to 1 by 2. We have tried to minimize the value so that here it can be maximized. So 3 plus, because when we are calculating range, it means our intention is what? Our intention is to calculate the maximum value of f of x as well as the minimum value of f of x. So keeping this in mind, we are trying to arrange all this, and we are trying to use the method which gives you the simplest way to simplify this expression. So finally we are getting this. Now the least value. So least value of this, it will be what? When this entire quantity becomes 0, because 3 plus anything, if it is anything more than 0, it means this quantity will get maximized. So just to get the minimum quantity, so 3 plus sum of two quantities, the sum of two quantities, it will be minimum if any of that quantity is what? Minimum. So this quantity is minimum because we can't change the value of this, that is a constant. We can have different value for different value of x. So this can be changed depending on different value of x. So it has to be minimized. So minimum value of this, it will be 0. So from it. Now you can say again, minimum value, it can be negative. It cannot be negative. The one thing is this entire quantity cannot be negative because you will get the imaginary. That is one thing. Another is this is a perfect square, so this will always remain positive. So the only option for this quantity to be minimum is that it should be 0. So this is equated to 0. So you have this. So minimum value of this, it is 3. Again it will be 0 at what? When this entire quantity becomes 9 by 4. 9 by 4 minus 9 by 4. And this will be 9 by 4. It means x minus 1 by 2. It should be equal to how much? 3 by 2. So that 3 by 2 whole square, that becomes 9 by 4. 9 by 4 minus 9 by 4, that becomes 0. So from simplifying that, you are getting x equal to 2. So the minimum value, it is coming as 3. And the maximum value, it was coming as how much? 6. So the range of the function, it will be what? Yani range of the function, it will be, because these are the values of f of x squared or y squared. Now we have to calculate value of f of x or y. It means you have to take the square root of that. So it is root 6 or root 3. So the range of the function, it will be lying between root 3 and root 6. So that way we can calculate all these values. I hope this is clear. So we will continue more problems. We will have lots of discussions, lots of problems over this, because calculation of domain and range, it is very, very important as far as this topic of calculus is concerned, the function, domain and range. Once you have clarity over how to calculate the domain and range, then problems in limits, differentiation, everywhere it becomes simple, because you will never have any confusion regarding the domain, of that function, the required function, wherever you are going for calculation of limits, calculation of differentiation, calculation of integration, everywhere we have to solve all these problems under the domain of that function also. So we should always be clear in our mind what will be the domain. We can't go beyond the domain, otherwise we will have some wrong answer or wrong relations. So in the next class we will have more questions. Thank you. you.